Welcome to part 3 of Competency 16. In this video, we will investigate the differences between mutually exclusive events and mutually inclusive events. By mutually exclusive, we mean that if we have two events, A and B, we say that if A occurs, then B cannot occur. And if B occurs, then A cannot occur. We represent this by the formula shown. By non-mutually exclusive events or mutually inclusive, we mean that the events can occur at the same time. This is represented by the formula shown, and the Venn diagram gives us a nice visual of the situation. Non-mutually exclusive events or mutually inclusive events are two or more events that can happen at the same time. As we solve these problems, we will identify if they are mutually exclusive or inclusive. Number 1, an ordinary number cube is rolled twice. What is the probability of getting a sum of 3 or a sum of 8? Okay, first we need to identify what our events are. First, we have one event where we have two sums of 3, another event where we're going to have five possible sums of 8. Okay, because we have no overlapping or repetitious situation between our two events, this is going to be a mutually exclusive problem. Now we know that if we roll the dice twice, we're going to have 36 outcomes. Our first event for the sum of 3 is 2 possibilities. Because we have the word or, we know that we're going to add. Then our next event, again, we're rolling the dice twice. That's 36 possible outcomes. And we have 5 outcomes that add up to. So we just simply add these together. So we're going to get 7 out of 36. Number 2, a coin is tossed 3 times. What is the probability of getting exactly 2 tails or getting 1 heads on the third toss? Okay, over to the side, you see all the outcomes listed, and then one is highlighted in pink. Well, this one's particularly important. Notice that we get 2 tails, exactly 2 tails, and the heads. Well, we need to exclude that one, okay? And then because we get those 2 things occurring at the same time, that is giving us a situation that is, let's say, repeating in a sense. So this is going to be a mutually inclusive. These are included in our list, and we need to take that out. That possibility needs to be taken out because we don't want both of them. We want one or the other. Okay, so what we need to do next is look at our events. Well, the first event is getting exactly 2 tails. Let's see, where do we have 2 tails? Let me change my color. 2 tails, 2 tails. Well, I have 1 here, and I have 1 here. I also have 1 here. We will take him out later, but we've got to include him at this time. So that gives us 3, if I could write, 3 out of 8. Okay, we have 3 out of 8. Then we're going to add him to the next event. What is our next event? one heads on the third toss. We'll go down and you're going to get exactly one third. One heads on the third toss. Well, that has more than one head. We can't use that. That has more than one heads. This one has more than one. That doesn't have a toss. That doesn't have a toss on the third. This one has two. This one has two. Well, this this has one, but that is saying 1 out of 8. That's misleading. What you really need to consider is that any coin has a probability of getting heads on the third toss. So the probability of getting heads on any coin, regardless if we're looking to see if it's in the third position, we're just talking about its individual probability. Okay, now we're going to subtract that one occasion, that 1 out of 8 in pink. Okay, all right. This is going to give us, well, you know what? Let's not look at that quite yet. There's another way that we can actually solve this. Let's put in the calculator first as we see it. Then we're going to use another method. Okay, so we have parentheses 3 divided by 8. Okay, then plus 1/2. And then we're subtracting the 1/8 and enter. Yes, that is going to equal 3/4. Okay, and that is 3/4. Okay, now there's another way to look at this. It won't always be accurate, work out the way you want it to. However, we can think of this a little differently. We can use our binom PDF by, here, let me clear all this out. We have too much stuff in here. Too much confusion. Okay. Second, vars, alpha, math. Okay, how many trials do we have? We have 3 trials, and we know on each trial that a coin is one. Oops. Let me back that out. Oh no, let's see. Okay, there we go. Okay, we know we have 3 trials, enter, then 1 divided by 2, enter. Okay, how many possibilities are we looking at? Well, for the first time, we need exactly 2 out of our 3 to be the same. So let's enter 2, enter, enter again. That gives us a nice decimal. Okay, let's add that to the possibility of only getting one of the items that we want. We only want heads. The first time or the first event, we wanted 2 of our possibilities. Now we only want 1. Okay, so second, bars, alpha, math. Okay, we still have 3 possibilities. It's still a half for our probability, but we only want one item to be what we want. Okay, enter. Okay, now let's add that to the oh no, it actually gave us our answer. I did add it. Okay, so that is going to give us our 3/4 that we wanted. All right, that's great. That's another way to do it. Okay, let's look at number 3. Okay, one card is drawn from a deck of cards. What is the probability of drawing a picture card that would be like Jack, Queen, Kings, as we've discussed before, or or a number 6. Okay, let's look at that. All right, how many picture cards do we have? Well, we have 12. And another thing that we need to discuss is this mutually exclusive or mutually inclusive? Well, think about it. Can we get these things twice? Are we going to draw twice or are we drawing at the same time? No, we're only drawing one card. That's it. Either it's going to be a picture card or it's going to be a number. So we don't have any repetition. So without repetition, this is mutually exclusive. Okay. We have actually, we only have one event, but we're measuring two different possibilities, one or the other. The first possibility is 12 out of 52, and we will add that to our next possibility of 4 number 6s in the deck. Okay, now let's just put that in our calculator as is. I'm going to use parentheses because it caused me problems with the order of operations in the past. Sometimes it's okay. All right, let's add that to parentheses 4 divided by 52. Okay, let's push equal and math, enter, enter, and that's correct. That's 4 out of 13. Number 4, what is the probability of selecting a retriever puppy with a red coat or getting a 6 with a roll of an ordinary number cube? Okay, the first thing that we need to ask ourselves is, can we roll a number cube and select a puppy at the same time? The answer is yes, we can do that. It sounds strange, but that is how we calculate this. That we can get it. We want one or the other. We don't want both. So there can be a situation where we we perform both events and get both at the same time. But that it really isn't what we're looking for. So we need to add up each column, get our totals. Okay, and this is 4 plus 10 red retriever puppies. That's going to give us a total of 30 puppies. Okay, that's our totals. All right, now what is the probability of selecting? Okay, we need one event for a puppy. Well, the first event is going to be 10 little red-headed puppies out of the 30. Then we will add that to the event of getting a 6 on a number cube. Well, ordinary number cube, that would be 1 out of 6. Goodness. Okay. Well, oh, now there it goes. That was a delayed reaction. Okay. All right. So this means that we're going to have the probability of 1 out of 6. Okay. Then we need to subtract the two events happening together. Okay, so that's going to be 1/3 times 1/6. Okay, let's put that in the calculator exactly the way it is. Let's type it in to prevent with parentheses and exactly the way we see it to prevent issues with order of operations. Okay, so that's 1 divided by 3. Notice 1/10 is 10 over 30 is 1/3. Excuse me. Okay, close your parentheses, plus parentheses 1 divided by 6. Okay, minus, I can go ahead and multiply those together, and that's going to be 3 times 6 is 18, so that is 1 divided by 18, 1/18th, and we push enter. That's a nice repeating decimal, but let's get our fraction. Okay, 4/19, and that is correct. Let's write this better. We have a probability of 4 out of 9. Oh, I still don't like that. Okay. Okay, 4 out of 9. 4 out of 9. Getting a red-coated puppy. Okay, next, number 5. A teacher created a chart that divides a box of 36 art supplies into categories of colors and pencils. What is the probability of the teacher will select a red art supply or get tails both times when tossing a coin twice? Okay, so again, we're going to need our totals because we have or, so we know what we're going to at least be adding. And before we even do that, can we select one of these colors and roll a dice twice? Technically, you can do them at the same time. So we will have a situation of repetition. This means our problem is mutually inclusive. So let's look at our first event, a red art supply. Let's go to red. Well, red, that is 16 total. Black, that's 13 total. Going to be adding these together. Then 7 yellow, and that equals 36 art supplies, which they had already told us that it was 36. Okay, so we have red, first event, 16 out of 36. Then plus, our next event would be rolling a, or no, excuse me, we're tossing a coin twice, and we know that a coin is 1/2. If we do that twice, we know that we have 1/4. You know what? I'm going to rewrite this. This time I'm going to eliminate the, oh, there it is. I'm going to eliminate those parentheses. Let's see how this turns out. So we have 16 out of 36 plus a coin being tossed twice, that's 1/4. Then we're going to subtract both of those events together. Now I'm going to do a little simplifying. So that is 4 out of 9 for the first event times the second event. Now let's put that in our calculator and see which option we have. Okay, so let's say 16 divided by 36. I'm going to push enter. Then I'm going to add my 1 divided by 4. Push enter again. Now I'm going to subtract my repeating situation. So I have 4 divided by 9 times 1 divided by 4. Close my parentheses. Enter. Let's see what that looks like as a fraction because fractions are the only options we have. So math, enter, oh, 7/12. We do have that option. So this means that we have the probability of selecting a red a red color supply or getting tossing a coin twice and getting tails with 7/12. Number 6. In a bag of marbles, 15 are white, 20 are yellow, and the rest are green. 2 marbles are selected randomly, one at a time, with replacement. What is the probability that at least one of these is white? Okay, let's think about this. We're going to have white, and we're saying that at least once. Actually, as we select them, we can have repetition. We can have, or we can get a white marble both times. So this means our problem is mutually inclusive. So we need to get rid of or subtract out the repetition. So we know that 15 out of 40 equals 3/8. So our first event is 3/8. And then if we roll again, we could get white again. We're asking the probability of rolling white a second time. Now we're going to subtract the repetition of getting white both times. Okay, let's put this in the calculator. We're going to take 3/8. Okay, oh, let's clear all of this out. This is kind of confusing. Okay, we're going to say 3 divided by 8. I'm going to push enter. I'm going to multiply that times 2. Same as adding them together. Now I'm going to subtract the 3/8, but I'm going to put 3 divided 8, close my parentheses, to the second power, because 3/8 times 3/8 is the same as to the second power. Okay, let's push enter. Math, enter, and that is our answer. 39/64. Okay, let's look at number 7. A particular bag of marbles contains 4 red, 6 green, 2 blue, and 5 white marbles. If 3 marbles are selected without replacement, what is the probability of picking all reds or all greens? Okay, let's go down and let's decide if this is inclusive or exclusive. Okay, well, we're going to get all reds or all greens. The question is set up to where we're going to get one or the other. So we know that our situation or our problem is mutually exclusive. The trick with this question is what happens in each event. The first event is for all red. Okay, then that means there's our red. And in our bag of marbles, looks like we have 17. So we know that we're selecting 3 marbles and we're not replacing. So that means we'll have 4 out of 17 times 3 out of 16 times 2 out of 15. Well, this is because we're not replacing the marble. And this is going to happen the exact same way for the event of trying to select a green marble. Okay, but green, we have 6. So that'll be 6 out of 17 times 5 out of 16 times 4 out of 15. Okay, let's put this in the calculator and see what we get. Okay, let's see. Let's put this, I say we put it all in parentheses for each event. So 4 divided by 17 times 3 divided by 16 times 2 divided by 15. Let's make sure that's correct. Yes. Close my parentheses. Going to add. So open my parentheses. 6 divided by 17 times 5 divided by 16 times 4 divided by 15. Close my parentheses. Enter. We need a fraction. So let's check and see what that fraction looks like. Enter, enter. 3 out of 85. And that is number C. Number 8. 2 cards are randomly drawn from a deck of playing cards in succession without replacement. That means one after the other without replacement. We're going to put it back. What is the probability that at least one of them is a picture card? Okay, the term at least one means we're going to have one or the other picture card or not picture card. Okay, and the next thing is, this is different. We need to ask ourselves, 2 cards are randomly drawn. This means that they're being drawn one after the other. Can they be a picture card at the same time? Yes, they can, and we will have repetition. You can draw a picture card and then again draw another picture card. It won't be the same picture card, but it'll still be a picture card. So we have a problem that's mutually inclusive. Okay, so now we need to think about our events. Well, picture cards, that event is 12 over 52. 12 out of the 52. Now, the next time that we draw a card, we still are going to measure or guide against the 12 out of 52. Okay? We're still measuring the same events. What's different is what we subtract. When we subtract, we're subtracting out a repetition. So what we're actually saying is, if we get a picture card on the first try, okay, we want to multiply that by not replacing it. Okay, it's always taken me a little bit of time to wrap my head around this, but what we're learning here really is, a review and using the calculator continuously. So we won't go into that. You may need to watch other videos to get a full understanding of this concept. So let's finish this out and see which one it is. We will take 15, 12 divided by 52. Now I'm going to push enter and say times 2. That way I don't have to worry about my order of operations. Now I'm going to subtract a repetition, which is 12 divided by 52 times 11 out of 51 cards. Okay, press enter, math, enter, enter, and we have C, 7 out of 17. Okay, now number 9. Number 9 is our last problem, and I really like this one. I think it's a nice example of a question, a solid question you might run into. 2 cards are picked out of a standard deck. What is the probability of both cards being either face cards or clubs? What you have to remember is those 2 cards, we don't know, and it doesn't say if they're picking them at the same time or if they're picking them one after the other. But what we do know is, regardless of that statement not being in our problem, we do know that we have a situation where a face card can be a club. So because we know a face card can be a club, that card in itself is a repetition that we have to exclude. I'm sorry, we have to subtract it out because it is included. And that means we have a mutually inclusive problem. Okay. Our events are also compound events, and they're a little different. Okay. We have 2 cards being picked out of a standard card. Because they don't tell us it's one at a time, they don't mention replacement. They are implying that those cards are being pulled out at the same time. So this means that for face cards, we have 12 face cards or picture cards. Here, let me make that to where you can read it. Let's try that again. Okay, there it is. Okay, let's try this one more time. 12 out of 52. So we're going to have to multiply that. We have 2 cards being pulled out at once, which is the same as without replacement. So now we have 11 out of 51. Okay. Now that's the first event. But now we have clubs. So we have we've done our face cards. So we're going to add clubs. We have 13 clubs out of 52. But we're pulling our cards out. 2 cards are picked. So that means we have without replacement once again. That'll be 12 out of 51. Then we have to subtract out the 3 cards that are face cards and clubs. And that's out of 52 times, remember we have 2 cards being pulled out. So that would be 2 out of 51. Now let's put this on our calculator. All right. I'm going to use parentheses so we don't get an issue with order of operations. Let's see. 12 divided by 52 times 11 divided by 51. Close our parentheses. Add. Open up parentheses. 13 divided by 52. Multiply 12 divided by 51. close our parentheses, minus 3 out of 52 times 2 divided by 51, close our parentheses. Now we enter. Okay, let's see what we have. We need a fraction. So math, enter. Oh, we have done something incorrect. 52. Something tells me our order of operations is having problems with the way we entered it. So let's try this one time, but let's do it in chunks. 12 divided by 52 times 11 divided by 51. Enter. Now let's add that to 13 divided by 52 times 12 divided by 51. And that's correct. Let's push enter. Now let's subtract that by 3 divided by 52 times 2 divided by 51. Enter. Let's see what happens. Oh, good. Yes, order of operations is always going to be an issue. So it was actually better not to use parentheses, to do each one at a time. And there's our answer, 47 out of 442.